Okay, y'all know y'all can see me real quick. I just want you to see the screen though, so bear with me. I'm still getting used to all this software, y'all. Okay, so here we go. All right, we're talking about we are on topic 1, module 2, lesson 4. So that's what we are working on. So we're doing activity 2. We're using equivalent ratio tables, probably one of the biggest things we need to look at real quick. So let's look at this. We're using equivalent ratio tables. Last time we did activity 1. Now we're on activity 2. And this is on page 217. Let me scroll down so you can see the number, page 217. So here we go. So we're using equivalent ratio tables. We know what these words mean. We know what the word equivalent means equal. We know what ratio tables are. They're just ratios, a list of them written in table format. So school has planned a pizza party for the 6th grade tomorrow. Tracy is in charge. I want a pizza party. Tracy is in charge of ordering the pizza for 450 students. So that's the total. We should probably label that. The pizza parlor said 2 pizzas would serve 9 students. So there's a ratio I can easily identify. Maybe I should write that. 2 pizzas, then 9 students. I'm not sure this is going to be helpful, but at least it's clearly written like I've taught you before. Tracy started a ratio table to help determine how many pizzas to order for 450 students. Well, looks like we already got a ratio. We already labeled the total. That's good information right there. So number 1 says, complete Tracy's table and explain her strategy to determine the number of pizzas needed for 400 students. That's what we're after. So we noticed we already had a ratio, 2, 9. Notice they wrote 2 pizzas, 9 students. We wrote it as a table. That's cool. So now they're saying we want 10 pizzas, 45 students. Remember, there has to be an equal ratio table. So they're wondering what's missing here in this 450. That's what we're trying to figure out. So let's look at some patterns we recognize here. So I noticed 2 became 10 if I multiplied by 5. 9 became 45 multiplied by 5. And that's true. As long as you multiply an equivalent ratio by a common factor, then you should get an equivalent ratio right here. Notice 45 to 450, we multiply by 10, but whatever I do here, I must also do at the other position. In other words, the top. I hate saying that word, the top, because I like numerator denominator, but it's not entirely numerator denominator, but it still partially is. So that's essentially what she did. We're using multiplicative reasoning skills. So first, Tracy multiplied both the number of pizzas and the number of students by 5, as we've seen here, by 5. And then she did it by 10. Oh, then what should this answer be, I wonder? I forgot to write that down. So let's correct that. So 10 times 10 is 100. So 100 should go in this block. So it's going to take 100 pizzas to fill 450 students. Let's actually write that down. 100 pizzas to fill, I can't even spell 2 today. 450 students. All right, we're going to go to number 2. So number 2 says, complete the table to show the number of pizzas to order the given number of students. Now I want you to pause the video and complete this table on your own and try to answer number 2 and 3 without me doing anything yet. I'll give you a little bit of practice. I want you to try that out yourself. So please give the chance to pause the video now and try to work it on your own. All right, so that should have given me enough time. So if we complete this ratio table, we notice it's a 2 to 9. So 10 to 45, interesting. I multiplied by 5 like we did before. And then we do 10 times something else, I wonder, which we already figured that out was 100 because they multiplied by 10. Notice this is not written in order, is it? I hate that. Normally in my class, you're going to separate and rewrite all this, but because we don't have enough room right now and you're not in my class, we're just going to fill this table out. So we're going to try to figure out how 9 became, I'm going to use green. So let me get rid of these 2 real quick. Times 5, times 5. All right, so continuing on, we notice 2 to 5. 2 times 5 is 10, and then we get 10 right here. 10 times 10 is 100. we could also go from this 2 position. That's what I'm going to do right here. So 2 times something is 135. 9 times something is 135. So that would be 30. Oh, wait, no, not 30. 15. 15 would work. I notice 9 times 15 is 135. 2 times 15 is 30. So we're going to try this next. Hold on real quick. Let me see if this works. Okay, let me try this next number. We'll have the blue. So it depends what values you want to start with. I noticed something times 270. 9 times 30 is 270. So 2 times 30 is 60. And we could go in that pattern. So the next one would be 50 and 200 and 300. We keep going in the pattern, you'll notice that 2 times something gives me 50. That's definitely 25. 9 times 25 is 225. 2 times something is 200. That's definitely a 10. 9 times 10, oh, I can't even talk. 100, not 10. 9 times 100 is 900. 2 times 100 is 200. 2 times something gives you 300. That's definitely 150. Let me try a different color. I like these organized. That's why we have a table that's organized. It's so much easier to do this. And we're definitely going to do that in class. So, and that's what we got for this one. Now let's look at number 3. Use the table of values to answer each question below. Please explain your explanations. How many students will 12 pizzas feed? Notice there's no 12 here in the pizzas. So we do know the initial ratio. 2, 9. So how many students will 12 pizzas feed? So 2 times something is 12. I wonder what number that is. Notice that's a multiple by 6. So 9 times 6 is 54. So the ratio is 12:54. So 54 people. How many students will 20 pizzas feed? The ratio is 2, 9. And I want 20 pizzas. Notice that's a multiple of 10. So 9 times 10 is 90. So 90 people. And for the last one, it says, how many students will 90 pizzas feed? I can't even say pizzas today. That's how tired I am, y'all. So we have 90 pizzas. Notice that's times 35. So 9 times 35 is going to be 405. So 405 students. So notice the correlation between ratio tables and just making ratios, noticing equivalent ratios. That's all one big thing organized all neatly, like pizzas and students. Like I said, in class, this will be a lot more organized because I don't even like how this looks. And that's a little confusing even to me, but that's all right. We're definitely gonna do some more of this in class. But very good work, students. That completes activity 2. And we're definitely gonna finish the rest of this tomorrow with some practice with one-on-one. All right, great work.